There has been quite a lot in the news recently about heat pumps, mainly connected with the government's decision to ban the installation of gas boilers in new buildings from, I think, 2035. Whether they actually instigate that ban or not, or maybe a few years after, isn't really the point. The point is that there will be a ban of gas boilers because it's the only way that we can become sustainable in the way that we heat our buildings. So the heat pump is something that some people have in their homes already, but many more people will have in the coming years. So how do they work? Actually, they work very similarly to an ordinary domestic refrigerator. The refrigerator takes electrical energy and uses it to move heat out of your food and into a heat exchanger at the back of the refrigerator and then into your kitchen. So if you put your hand behind the fridge, it feels warm, and that's heat that used to be in your frozen food and in the other items in the fridge. It's simply been moved from that food into the kitchen space. A heat pump does exactly the same thing. It uses electrical energy to move heat from outside the building, where we don't need it and can't really access it, into the building, where we can use it to keep comfortable. So the heat that's outside the building might be in the ground outside the building in the form of a ground source heat pump, or it might be in the air outside the building. That would be an air source heat pump. And in some cases, the heat can be in a river or in a lake outside the building, a water source heat pump. Either way, the basic refrigeration cycle, which is similar to the one in a fridge, will do the same job in terms of moving the heat from the source outside the building to where we need it inside the building. Once the heat is inside the building, it can be used for heating the space to make us comfortable, and it can also be used for heating hot water. The heat pump can achieve the same temperatures that we need out of a gas boiler for exactly the same purposes. Heat pumps have to be used with water storage if they're to be used for heating hot water, so you will need some kind of domestic cylinder. I mentioned in the fridge, the compressor takes electricity and uses it to compress a refrigerant gas, and it's exactly the same in a heat pump. The compressor is the device that takes the gas coming into it and increases its pressure, and in doing so also increases its temperature, so we get hot gas coming out of the compressor. The hot gas then flows into a heat exchanger within the heat pump, and that can exchange heat with water, which is pumped around your radiators or around your underfloor heating or into the hot water cylinder, or in some cases, if it's an air-to-air heat pump, for example, the heat exchanger will put that heat into air directly in the building. But either way, the heat comes out of the hot refrigerant gas into the building and is used to provide comfort for the occupants. Having done that, the refrigerant is then a bit cooler, and it then circulates around the heat pump circuitry through a device called an expander. Now the expander, as the name suggests, changes the refrigerant gas from a combination of a gas and a liquid after it's lost some of its temperature back into a gas. It expands this liquid back into a gas, and in doing so drops its temperature considerably. The temperature of the refrigerant is now very cold out of the expander, and it circulates out of the building into another heat exchanger, which is used to pick up heat from outside the building and warm up this very cold refrigerant, making it quite a lot warmer. So whether it's taking heat out of the air or out of water or out of the ground, the refrigerant is now significantly warmer and comes back into the building and back into the rest of the heat pump circuit. Having done that, the refrigerant gas is put back into the compressor again, and it's compressed, which makes it hotter, and it carries on around the circuit. So we have a series of compression and expansion, heat being added outside the building and heat being taken out inside the building, which works to move heat from where we don't want it to where we do want it. An example of how this works and how impressive it can be is in a Norwegian city called Drammen, where a heat pump system, a very large city-scale heat pump system, is being used to extract heat from a fjord outside Norway into the city heating system itself. So it's not going directly into one home, it's going into a district heating system and heating many homes. That's an example of the power of heat pumps. And using this type of technology, we can in effect magnify the utility of the electricity that we have in the form of kilowatt hours of electricity becoming kilowatt hours of heat, we can turn 1 kilowatt hour of electricity into 3 or 4 or maybe more than 4 kilowatt hours of heat, a much more energy efficient use of electricity than conventional electric heaters.